There we go.
Okay. So, for those of you who saw the other announcement, so there are 7 units left. There's 7 units total now because they took out the last 3 units. There was normally 10. And so we have 27 sessions left before we want to be done, which is several weeks before the test. So our goal is to get most of the units done in 3 or 4 sessions each, if possible. Um, so the first unit is the longest, and that's because all of physics is based on that. Um, but hopefully you all understand that for the most part. If there's any questions and we need to go back to that, let us know. Unit 2 is dynamics, and my hope is that Mr. Florence taught you guys that well enough that we don't need to go over it that much. We're gonna see how that goes, but hopefully we don't have to spend that much time on Unit 2 so that we can start going towards what the harder units are, which is 3 through 7. But we're going to start with topic 2 dynamics anyway, just to make sure that you guys understand. Um, so, Alan, do you want to start? You want me to start?
Uh, I can start us off. So, for the main part of dynamics is uh, like forces. So just your standard F equals ma, uh, and then from there you move on to systems. And systems is it's kind of hard to like draw systems, but it's when you have objects that are related closely enough that you can treat them as one. Like for example, if you have two boxes connected by a string, and then a force applied to them. So I'll just quickly. I am on camera, right? Where is the?
You could just hit moderate at the top and
All
then
right,
move the screen. There you
there
go.
you go. Yeah. So if you just like for example, if you're gonna make a system and then you have like a force here, a tension, you can treat all of this as one system, and you don't have to do the tensions in between these two boxes. Uh, you can just take their total mass and use F equals ma and get the acceleration.
So,
Uh,
and also on that, I'm hoping the answer is yes. But does everyone understand the equation F equals ma?
does anyone?
Yep.
Was that a yes or no? I couldn't tell.
Yeah, that's a yes.
Okay.
Yes.
Okay.
Yes.
Okay.
Good. 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 Getting off to a good start.
Okay. All right. Okay. So then, uh, beyond that, there is friction. Uh, if I were to say that something has a static coefficient of friction of like point 0.25, would is there anyone who doesn't know how they would use like uh the mass of a box to try to get the friction force? Or does everyone understand how to do that? Like if I gave you, let me try to like write out a problem real quick. Um, oh my God, that's tiny text. Hold on.
Also, while he's doing that, I wanted to ask. So, does everyone here understand the difference between static friction and dynamic friction, and what causes one or the other, or when you would use one or the other?
Could you go over that real quick, actually?
Yeah.
Yeah,
So,
it's a bit on
if you have something heavy on your desk right now, that would help in the demonstration. But in well, I'm gonna try. So, for example, I have a calculator here. I know you can't see it, but I can push on it a little bit and apply a little bit of force, and it's still not going to move, right? There's a certain point where the force that I apply passes a certain threshold, and then it starts moving. But below that, between applying zero force and applying whatever that threshold is, it doesn't move. But I'm still applying force, which means that the surface that it's on, in this case my desk, is applying a force that is equal and opposite to the force that I'm applying. During that whole period where it's not moving, but I'm applying a force, that's called static friction, because nothing's moving. As soon as I start, as soon as I pass that threshold and it starts moving, that's called dynamic friction. And the equation, so most objects have what we would call the coefficient of static friction and the coefficient of dynamic friction, which are the values that we use to calculate what the force of the surface it's on would be when we're experiencing those two frictions. So, if the mass of something was 10 and its coefficient of and I think Alan's going to go over this in a second as well. But if the mass of something was 10 and the coefficient of static friction was 0.1, so all you have to do is think about, what is the force of the surface it's on? What force does that have to apply to keep that object up? And so, so if an object is 10 kilograms and it's on a surface, right? The force downwards due to gravity is going to be that times g, which we're just going to say is 10. And so that would be 100 newtons downward, which means that the surface it's on has to apply 100 newtons upward, right? And since if we're talking about static friction, and we said that the coefficient of static friction was 0.1, we can multiply that force of the surface on the object by 0.1, so 10. So we would say that the surface that it's on will apply up to 10 newtons against the force that I apply to keep it in place. So if I were to apply 5 newtons of force in the forward direction, well, the surface is going to apply 5 newtons of force back. If I apply 9 newtons of force, the surface is going to apply 9 back. 10, it will still apply 10 back. But over 10, then we're into, at that point, we know the object has to start moving because the force can only apply at most 10 newtons while it's still static. So once it's over 10, then we know we're in dynamic friction, and we can use the same equations, but using the coefficient of dynamic friction to calculate the force it applies. Are there any questions about that? Okay, back to you, Alan.
Alright, so just for like a quick sample problem. You have a piano, weighs 500 kilograms, and there's a static coefficient of 0.35 and a dynamic friction coefficient of 0.2. And there's a 2000 Newton force applied in just some direction. We'll just say it's like to the right. So how would you approach this problem? Anybody?
One of them is deafened, by the way, so we really only have 2.
Yeah, I know. Alright. We have any guesses? I'll even take wrong ones. Doesn't matter to me.
So just start off by thinking, if we want to know the friction force, what are the other things we need to know? I just talked about this in my example.
Yeah.
Okay, so one of the things you need to know is the coefficient of either static or dynamic friction, right? What is the other thing that you need to combine with the coefficient of friction to find the force of friction?
Wasn't it the normal force?
Yes, it is the normal force. Continue.
So, if we combine, I need to find my calculator, actually calculate this out because I haven't done that yet. Where did my calculator? Whatever, I'll just use my phone. So, so we have a 2000 Newton force, and so first we need to find the maximum static friction force, because if the 2000 Newton force doesn't exceed it, then it just won't move. But if it does, then we can get the acceleration. So where is my calculator?
So first, we just said we need the normal force. How can we get the normal force from the numbers we have in the problem right now?
Wouldn't it just be weight force times gravity, which would be 10, you said?
Mm-hmm. Correct, yes. So we would just do 10 times 500 because it weighs 500 kilograms times the gravitational force
Yeah.
or gravitational acceleration.
Yeah. So you get a result of 5,000 Newton gravitational force, which then is a 5,000 Newton normal force because of Newton's third law. And then you multiply that by 0.35 to get the maximum static friction force, which is 1,750 newtons. So because our 2,000 Newton force is greater than that, we know that it will move, and then we need to find the uh, dynamic friction force, which you just find by doing the same thing again, but multiplying it by the 0.2 instead. So it'll just be 500 times
What'd you say?
10, and then
What was
times 0.2, huh?
what was the coefficient for static max again? 17
For
something.
static max, 0.35 is the coefficient.
No, not the coefficient, just the force.
There's the force, it was 1,750. Yeah, and then the dynamic friction force is 1,000 newtons. Yeah. So then our net force would be 1,000 newtons as well. And then in order to find acceleration, you just do F equals ma. We have a 1,000 Newton force. Divide by m, and you get acceleration, which would be 2 meters per second.
Okay, and then we take and the just like we always know F is equal to ma, so we know that uh, the net force of 1,000 newtons is equal to mass times acceleration. So mass is 500 kilograms, and the acceleration is a. And if we solve for a, I'm doing this right, correct? Yes.
Yeah.
That's going to be 2 meters per second squared.
Hmm.
So just to sum up, the first thing that Alan did was find the coefficient, the force of static friction max, or the maximum force of static friction, just by taking the normal force times the static friction coefficient. If the force that we applied was less than that number, the object wouldn't move, and the answer to what's the acceleration it would be 0. But since it is greater than 1750, then it is going to move. So then we move to dynamic friction. You find the force of dynamic friction, which was 1,000. Find the net force. So we know we're applying 2,000 and it's resisting with 1,000. So there's 1,000 total newtons is the net force. And then you just use F equals ma and solve for a to find acceleration. Is there any questions about how that works?
Is anybody still confused, or do you guys think you have it now?
Can you repeat one more time how you got the dynamic friction force?
Yeah. So the dynamic friction force, you would find the normal force, which you would get from multiplying the mass by the gravitational acceleration, which is always, as long as you're on Earth, going to be 10. So you'd get 5,000 newtons for your gravitational force, and then because of Newton's third law, it would be a 5,000 Newton normal force, and then you just multiply that by your coefficient, which is 0.2, and you'd get a 1,000 Newton dynamic friction force.
All right, got it.
Okay. So are you guys comfortable enough where you think you could solve something like this on your own if you had to? Silence, woohoo!
I don't know whether that's a yes or a no.
For dynamic friction rather than static friction.
Sorry, could you repeat that?
So just making sure whenever you have a problem kind of like this, and you're figuring out either the coefficient of static friction or dynamic friction, and you solve it the way you did, like um, like the part where you solve for either static friction or dynamic friction, like when would those apply?
Okay.
Like I'm not sure which one you're solving for. Sorry.
Okay. So it's basically you solve for your static friction first, and you look to see if the force that's acting on the object is greater than the maximum static friction. If it's less than the maximum static friction, the object just won't move. If it's greater than the maximum static friction, then you have to calculate the dynamic friction force, and then get your net force and calculate it that way. Does that make sense?
Yeah. So then, in dynamic friction would be you would have to plug in. How would you solve dynamic friction actually?
Uh, it would be the same way with static friction. So you just take your normal force, multiply it by the coefficient, and then that would be your maximum
They're
dynamic
both
friction.
solved the same way. You just take
Yeah.
your normal force times the coefficient. It's just the coefficient that changes.
Mhm.
Oh, okay. All right. Thank you.
No problem.
But yeah, you always start with static friction always, and if the force being applied is greater than the results from your static friction calculation, then you do dynamic. If it's less, you don't need to do the dynamic part because you know it's just not going to move. But yeah, any other questions on this?
Alrighty then.
Okay, cool. Um, Let me double check that that's pretty much it for this part. Oh, we
Mm.
need to do free body diagrams.
Yeah. That was the one thing that people really did score well on in the I think at the beginning of the year. So
Did or didn't?
people did do well on the free body diagrams. It was one of the
Okay.
only things that people scored really high on.
All right. Well, then this should be easy. Um, so if there is a block that is in free fall on Earth, um, what would its? You're just gonna have to describe it because we don't have anything set up for you guys to draw. But what can anyone tell me what the free body diagram would look like for that situation?
Sorry, can you repeat that? Or
It would just be whatever falling with. I believe it would be just one arrow pointing downward with the weight.
Yes.
Yeah.
Alan, can you turn off moderation so I can control?
Yeah.
Thank you. No, moving. Stop. Nope, I did not mean to do that. Go back. All right, so yes. So if we had an object here, which in 3D robot diagrams we always represent as a point particle. Let me actually move the screen. There we go. So we always represent as a point particle. If I have an object in free fall, right? By definition of free fall, the only force acting on that object is the force of gravity, right? So that would just draw one arrow downward on that, and that force is equal to the weight force. Does that make sense? Is anyone confused by that? Okay. So now imagine we have a table and
That
we
makes
have a
sense.
book, high quality book. Okay. And that book is stationary on the table, it's not moving. What would the free body diagram for that situation look like? Anyone can say anything.
You have your weight force and your normal force.
Yes. So we always have our weight force because we're on a planet that has gravity. So that's equal to the weight force. But like we said, it's not moving. So the table is also exerting a force that is equal and opposite to the weight force, and that's the normal force. So that normal force, which is equal to the same magnitude as the weight force. And so the net force is 0 and there's no acceleration. Okay, so let's do similar situation. We have this book on the table, and someone is pushing this book that way on the table, but it's not moving yet. They're exerting force on the book, but it has not started to move. What would the free body diagram for that situation look like?
You have the applied force of the whatever's pushing it, and then you would have your static friction force going against, correct?
Mm-hmm. Yes, because it's not moving. That's correct. Is there anything
Also,
else?
quick question.
Yeah.
So today we were given a worksheet on I believe it was like electrostatic energy.
Mhm.
And like I'm not sure if like we're gonna have enough time by the end of it, but if we do, could we go over it?
Sure. You said electrostatic imaging?
Energy.
Oh, energy. Okay. Yeah. Um, although that's one of the units that was taken out this year, isn't it?
Was it
Really?
taken out for IB2 or just AP?
No. IB still has it. But AP they
Uh,
took out 8, 9, and 10, and 8 is electric charge and electric force. So, Alan, I'm right on that, right? That was one of the ones that was taken out, correct?
Yeah, but these people here are all IB students.
Oh, okay. Never mind. Got it. All right, we're
Yeah.
good. I was about to about to be very confused.
Yeah.
Okay. Yes, we can go over that.
Thank you.
So on this free body diagram, let's just finish up this part first. On this free body diagram, is there anything else, or is it just those two forces?
No, you would also have the weight force and the normal force.
Yep. If I can draw, and I know I wrote that backwards, but you get the concept. So there's 4 forces. There's the normal force, the weight force, and then the pushing force and the static friction force. Alan, is there any other things we need to go over through body diagrams?
I don't really think so.
Okay.
That's probably it.
Well, that's dynamics, right? Am I missing anything, Alan?
No, that's it. That's
All right.
dynamics.
So that's all of Unit 2 done in less than a session. Very
Yeah.
good. Um,
So here's the
so
question though. Do we want to go on to Unit 3 now, or do we want to quickly cover what you guys are asking for? Because I'm assuming you guys have a test or something coming up that you need to prepare for?
Well, we started the unit earlier at the beginning of this week, and we have a worksheet due on Friday at midnight, and I'm just like not understanding what we have to do for it.
Yeah, we don't get it.
all right. So yeah, let's just go over that. We'll do Unit 3 next time, and hopefully there'll be AP people here as well. Anyway, so do you want to like share the worksheet if you can,
Yeah.
or do you
Yeah,
want
where do you want me to send it?
an IB
An
homework?
IB
Fine.
homework help?
Yep. What was the unit you guys did before this one? Do you know?
I think it was waves.
Okay.
Yeah, waves.
Just checking. Okay, let me pull up my formula sheet.
Alright, so I'm just gonna stop the recording now because I'm sure the AP people aren't going to be
Yeah.
version of this, and this is all that we have.
Well, just start another. Oh yeah, this is the only. Okay, never mind. You're right.